Okay, good evening. Thank you everyone for joining. So this is going to be our third live session on this channel. So in today's session, we want to discuss about the introduction to pile foundation design. So we are going to going through this presentation. So this class is going to be divided into two. So we are just going to take about 30 to 40 minutes for this class. So it's not something that is going to take long. So if you have any question along the class, so you can leave it in the comments. You can drop it in the comment section. When I finish with the presentation, I will try as much as possible to respond to your questions. So to start with, we want to discuss about pile foundation. But generally, in construction, we understand that there are two major types of foundation design. So you can either have a shallow foundation and we also have deep foundation. So the definition of shallow and deep depends on the size of the foundation with respect to the depth of that foundation. So when you say a foundation is shallow, that means the depth of the foundation is not as much compared to the other size, let's say the width of that foundation. And then when you say a foundation is deep, that means you are trying to say that the depth of the foundation is much more significant compared to the width of that foundation. And we all know the typical examples of shallow foundations that we have. We have the pad, the raft, the strip foundation, combined footing, and so on. But in terms of deep foundations, if you look across all text, that is design books or construction text, you see various types of deep foundations. So some of them include casings, shaft foundation, well, and also pile. But if you look at them critically in a general sense, you see they are more or less talking about pile foundation, but in different methods of construction. So, but in this video, we want to focus on pile foundation. So, what do we mean by pile foundation? So, a pile is just a long and slender foundation members that can either be driven into the ground or cast in situ into the ground. So you either drive it by mechanical force or you excavate and then you pour and then you place. So, but before we dive too much into pile foundation, the various types that we have, so let us look at the reasons why we might need to use pile foundation in constructions. So the reason why we might need to employ pile foundation, I've listed them here. So the first of them is when the upper soil is weak to support the intended load. So this is a typical example of when the load coming on the soft on the foundation or on the soil is much more higher compared to the capacity in which that soil can bear. So in that kind of situation, you might tend to go for a deep foundation, in this case, pile foundation. So, and then another reason why you might need to go for pile is when the soil below that once the soil below the structure are either expansive or collapsible. So when we say a soil is expansive, what we are trying to say is when the moisture content of that soil, as the moisture content of the soil changes, either increase or decrease, the soil tends to swell or shrinks. So the moisture content determine a lot about the property of that soil. So this kind of soil is not really a good soil to lay your foundation into. So in that kind of situation, it's better you go for a deep foundation where you know that all the load will be transferred to a much more high density soil strata. And then another reason why pile foundation can be used, or in situations where pile foundation can be used, are structures subjected to uplift force. So this kind of structure include transmission towers. So our transmission towers, they are usually on pile foundation, and then offshore platforms. So this kind of structure, they are subjected to what we call uplift force. So the force that try to uh, for example, and a typical example of uplift force is wind. When the wind is playing the majority of the is contributing to the majority of the forces on a structure. So like the transmission tower, offshore platform. So in that those kind of situations, it's always safer to support those kind of structure on pile foundation. And then we also have when we in terms of heavy load structures. So heavy load structures like bridges, even though in some situations uh, a shallow foundation can be enough to support some kind of bridge, but generally we used to employ deep foundation. And apart from the structural advantage, we also have the environmental advantage. You know, heavy structures like dams, bridge, they are usually designed for to last like 100 years, 200 years sometimes. So if you design those kind of structure with a shallow foundation, even though it works structurally, this foundation can be exposed to erosion and a lot of environmental issues. So the best foundation you can use to support heavy structures are, are pile, deep foundations. And then we have the last case, the last point, unpredictable underlying strata settlement. That is when the settlement is unpredictable or it's much more above the allowable or the limit. Then in that case, you tend to go for pile foundations. So these are some of the reasons why we try to provide pile foundation in construction. So I know that the first two are the common one when the loads, the soil is very weak and they cannot carry the intended load. So that the major ones that we know in practice. So now let us now talk about the different types or forms of pile foundation that we have. So in order to explain this, if you look at various textbooks, it is generally divided into about three forms. So, but to make it simpler and easy, I'm just going to explain it using this diagram. So, you can classify pile foundation into three major classes, either based on the function, or let me say based on the type of load they support, or based on the material you are using for the pile foundation, or based on the installation method. So those are the three ways or three forms in which pile foundation can be classified. So the most common one, or the one that is much more concerning to designers, let me put it like that, the ones that is much more if you are a structural designer or you are a designer, what concerns you the most is the first one, which is based on the function. So this image try to explain it. So based on the function, you can see that I listed about 8 different types of pile. We have the end bearing pile, friction pile, tension, compaction, anchor, sheet pile, and laterally loaded pile. But the most common one in practice are the first two, the end bearing pile and the friction pile. So this is just based on the mechanism in which they support the load. So in terms of the end bearing pile, if you look at this image I'm hovering about, you see that the load is coming from the superstructure and then it is being exerted on the pile. So and you can see clearly that in end bearing pile you have soft soil and then the load is actually transferred to the hard strata. So if the hard strata is around 30 meters down, 50 meters down, so the load will only be supported at the end part of the pile. So that's why they call it end bearing pile, because the load is transferred from the superstructure down to where we have the high density layer of soil. So that's the idea behind the end bearing pile. But in terms of the friction pile, what happened in friction pile is, let's say where we can find hard strata is very unpractical in terms of uneconomical. For example, you are designing a three suspended floor, let's use that as an example, and then the total height of your building is around 18 meters tall. That's the total height of your building. And then at the end of the day, based on your investigation, you find out that the hard strata where you can actually place your pile if you want to make use of the end bearing system is going to be at a depth of 120 meters. Is just an example. So it will not be practical for you to provide such kind of foundations at the end of the day, that the depth of your foundation is much more larger or is much more higher compared to the overall height of your building. It does not make sense. So that is where you can combine, you can use the friction pile mechanism. What happens in the friction pile is the load is transferred by means of friction along the surface of the pipe. So what happens is, with different layers going down into the soil, when if the stiffness of that soil increases with increase in depth. So let's say you have 10 strata. So the first strata has a particular stiffness. Then the one below it is more stiffer. Then the one below it is more stiffer. So when you accumulate all those stiffness, they will be enough to support the intended load for the superstructure. So that is the idea in friction pile. So the friction pile does not really transfer the load to the hard strata down. What it does is it support the load based on the resistance between the pile surface and the friction of the soil. So, but practically, what we have practically is the combination of the two, both end bearing system, support system, and then the friction pile support system. So these are the two major classification of pile based on the function or based on the way they support loads, end bearing and friction. As I've mentioned, in practice, geotechnical engineers usually make use of the two if it is possible. If it is possible, where it's possible, they try to make use of the two. When you make use of the two, it tends to give you a much more economical design. So, and then based the other classification is based on the material. This one is very simple. It just depends on the kind of material you use for your pipe. You can have a timber material, concrete, steel, and composite. That is combination of concrete and steel. So we all know that when we talk about concrete, we mean reinforced concrete. So generally, the common type of pile based on the construction material is the concrete pile. And then we have the other classification based on the installation method. This is very important because the installation methods uh, the installation methods determines a lot of things, or it affects a lot of things. So you can either install pile in two ways. We have by driving, that is you forcefully drive the pile, which is usually, if it is going to be, this is usually applied for if it's going to be steel member or if it's going to be timber. I'm talking about the construction material of the pile. So you drive it, or if it's going to be concrete. So if it is going to be concrete, it has to be precast. And then you drive it into the soil using pile hammers or any other driven equipment. So it is usually driven vertically or at an inclination. So you can drive pile into the soil mechanically by using hammer or other driven equipment. So using this method generates a lot of vibrations. So that is why the construction method is very important. So and then the second one is the cast in situ pile or the board pile. This one is the most common one. So what happened here is that you have to drill a hole, you excavate, not really excavate, you drill a hole and then you fill that hole with concrete. So this is usually done for concrete pile, majorly for concrete pile. Other types of pile like timber, steel are usually driven. But you need to understand when to use driven pile and when to use cast in situ. So in practice, the geotechnical report is going to is going to advise you on the type of pipe you should recommend, either cast in situ or driven. So based on the condition and the environment and the impact of that exercise on the environment. And then lastly, based on the installation, we have combination of driven and cast in situ. This can also be achieved. So now that we've talked about the different types of pile and also understand some of the examples of deep foundation, let us now talk about a pile system. When we say pile system, what are we trying to say? We are trying to say that how does pile actually support loads applied on them as a foundation. So when we talk about pile system, we are talking about how pile works. So the way pile works is actually shown using this diagram here. So generally we have the load coming from the superstructure. This example is showing a column. Sometimes it can be a piers from bridge, or it can be any loads coming on the pile. So this load is first of all received by the pile cap. So this pie cap is actually serving four purposes. The pie cap is serving four purposes. So pie cap is very important. Pie cap is just a base where the superstructure is received and the load is also received before being transferring that load to the pile itself. Then the pile cap is just like something that holds the piles together. So then after the pile cap, you now have the pile itself. So what are the purposes in which a simple pile cap can serve? So I've listed them here. One of them is to receive the load from the superstructure. So the pile cap will serve as a receiver. So it receives the load from either the column or the piers in terms of bridges. Then after receiving the load, it now distributes these loads to the piles. This purpose is very important because practically it is understood that loadings on pile are not evenly distributed, like completely 100%. It cannot be 100% evenly distributed. What we are trying to say is, let's say you have a superstructure load of 1000 kilonewton and they are supposed to be supported by four piles. So theoretically, or what you think is that all the piles are just going to be having 250 kilonewton each to support that load. But in practice, that this is not actually what happened. Some pile can have slightly higher loads compared to other piles. So that is the reason why the pile cap is important. When your pile cap is properly done the way it should, then your load will be as even as possible. So that is why we said one of the purpose of the pie cap is to evenly distribute loads from the superstructure to the pile itself. And then another purpose of the pie cap is to prevent uneven settlement. And then once it prevents uneven settlement, then the structure will be structurally stable. So the purpose of the pie cap is to receive loads, just as a recap, to distribute this load as even as possible, and then to prevent settlement, and then to provide structural stability. So nowadays you see some some will practice a pile in such a way that they neglect the pile cap. So if this is not properly done, like the case of raft plus pile foundation, in which the raft slab is going to serve as a pile cap. But if you are not doing it that way, that means you are doing what you are doing is not right. So you must have a pile cap so that you can receive the load, then distribute the load as even as possible, and also to prevent settlements, and also to provide structural stability. So these are the main purpose of pile cap in a pile system. I hope this is understood. So let's now talk about some design criteria that you should have when you want to design pile, or when you are detailing pile foundation. This is important. So I'm going to classify the criteria into two because we have two major elements in a pile system: the pile itself and then the pile cap. So if we talk about the pile itself, so the first thing you should have in mind is the minimum spacing between your pile. When you have more than one pile, you can, even though a monopile system is possible, that is, you only have one pile to support the load. But what is common is pile is usually in group, that is in two, three, four, five group like that. So when you have a friction pile, in friction pile, the mechanism of supporting the load is using the skin friction between the pile system, either it's concrete or steel or timber, and the soil. So the friction between the two, that is the mechanism in which friction pile used to support load. So one of the rules that you should follow to have a proper system is that the minimum spacing between the pile should be 3 times the pile diameter for a friction pile. And then if it is an end bearing pile, it should be twice the pile diameter. Let's just put it like that, twice the pile diameter. And if you look at it critically, you can understand the reason why. Because in friction pile, you need as much area as possible so that the friction resistance will be as high as possible. So that's why the spacing is said to be thrice for friction pile, while for end bearing pile, twice the diameter of pile, or the perimeter of the pile, sorry, twice the perimeter of pile is enough. And then the last point in terms of the design criterion is that for a bored pipe that is in cast in situ, bored pipe can be enlarged at the base for better resistance. Your pile, let's say you have a pile size of 600 mm. So at the base where you have the hard strata, it will make sense if you enlarge it, that is, you increase that base a little. You increase the base a little to have a better resistance. And then for the pie cap, the design criteria I just listed here is a rigorous way, or let me say a rule of thumb, that you can use to calculate your pie cap depth. So the pie cap depth is a factor of the pie diameter. So it is governed by this formula, is equals to twice the pie diameter plus 100 mm. So it means that if your pie diameter is 450, so your depth of pie cap should be in the range of 2 times 450 plus 100. So that will be around 1000 millimeters pie cap depth. So if this is understood, now we understand why we have pile foundation, and also some of the examples and classification of pile. And then we have also highlighted some design criteria that you need to follow while you are detailing or designing your pile system. So let's take a worked example in order to finish this chapter. So we are going to look at this example. So this example is, we want to determine the number of pile that we will need for our loadings, and then we also give a suggest a depth of pile cap. So the question goes like this: determine the number of piles of 450 mm diameter piles carrying a safe working load of 300 kilonewton. Based on the investigation report, each of these piles has a safe working load of 300 kilonewton required to support a column subjected to 2500 axial load. So this load is a service load. So the question asks us to determine the number of piles required, and then the depth of the pie cap. You should suggest the depth of the pie cap. This depth of pie cap formula is not actually absolute. When you do your actual design, you might end up with a depth slightly lower or slightly higher, but you should know that your depth should be in this range. This is just giving you a guideline. So the solution to this, so if we take the later question to suggest the depth of the pie cap, this is using the formula that I listed in the previous slide. So the depth of our pie cap is 450. So we just take 2 times 450 plus 100 mm. So that means the depth of our pie cap should be in the range of 1000 mm or 1 meter. So when you do your design and then you end up with something like 450 depth of pie cap, 500 depth of pie cap, you should know that something is wrong. Then we also have the how to calculate the number of piles. To calculate the number of piles, we have the column load divided by the pile working load. So if you do this computation, you are supposed to have something like 8 point something. The column load is 2500 kilonewton divided by the pile working load. So this pile working load is subservicity load of the pile. So divided by 300, so you have 8 point something. So you can approximate that to 9 piles. So this is how to calculate the number of piles needed. You just need to know the service load on the from the superstructure in kilonewton form, and then you divide it by the working load of your pile, of each pile, and then you approximate it to the nearest whole number. So in this case, we have 9 piles. So these are some of the things we want to explain in this section on pile, introduction to pile foundation design. So, but before we go, I would like to thank you guys for joining this session. Really appreciate your time. So if you want to learn more on pile foundation design and detailing, you can check out our website chefdinacademy.com, or you can message us via WhatsApp using the contact displayed. So, but before we end this session, I would like to introduce you to one of our latest course on pile foundation design. So this course is quite straightforward. So if you have any question, you can drop it in the comments now. Also, um, so this is the course. You see the link to this course in the description of this live session. So this course is pile foundation design and detailing. So what you are going to learn here is you understand the fundamentals of pile foundation. This includes the types of pile, which we've explained some of it in this video, the selection criterion and geotechnical consideration for pile foundation. And then you also have software design. So we are going to be designing, analyzing and designing pile foundation using Tekla tests and Prota structures. And then we calculate loads and load distribution on the pile. Then we also explain how to do a proper pile group, that is optimize the layout and spacing for stability. Like I mentioned, the pile cap is very important, but the arrangement of your pile within this pile cap is much more important, so that you can have an even distribution of loads. And then we have detailing and drawings. So here we are going to show you how to properly detail your pile cap and also your pile system. And then we have some case study on building projects in order for you to fully understand this concept of pile foundation. So the course is about 2 hours plus long, and then you have access to video course, study materials in PDFs, no design requirement or no prior knowledge required on this topic. And then we are actually selling the course at 50% discount at the moment. So you can use this opportunities, awesome course on pile foundation. So if you have question, please, you can drop your question at the comments, and then I will try as much as possible to respond. So I will just give 5 minutes for question. So I'm going to be live with us in the next 5 minutes to answer your questions. Okay, so someone is asking that, please, what should be the length of reinforcement in a 10-meter depth, knowing that the standard length of reinforcement is 12 meters? Thanks. Well, actually, in design of pile is usually designed not to be subjected, especially like I mentioned, we have different type of pile, the with supporting different loads. So when your pile is not subjected to lateral loadings in such a way that it is only subjected to compression loads, axial loads from column or piers. So what is important in this case is the minimum reinforcement required for the pile. So in this kind of problem, what is usually common in practice is, what people do is they will do a 2 meter without placing reinforcement, just concrete, and then they will reinforce the remaining 12 meters. So that is what is usually common in practice as regards to your question. So if you have a 20-meter depth, so what they do is they do 8 meters without reinforcement, and then they reinforce the remaining 12 meters. So and then the idea behind it is your pile is only taking the compressive load, and you know that reinforcement is only present for tension, that is to resist movement on the members, that is on the pile members. So since you're only subjecting your foundation to compression loads, no tension loads, so there's no need, technically there's no need for reinforcement, but we provide reinforcement usually using the minimum reinforcement of that section, you get. So as far as I know, that is what is being practiced. So I have about 3 minutes left for questions. So on our website, you learn, you have a lot of courses that you can explore if you are new to this channel. So we have different courses on design. So now we are focusing majorly on structural design. Our next couple of courses is going to be on other aspects of civil engineering. So you see courses on pile foundation, raft and ribs and raft, waffle slab design, flat slab design and detailing, steel roof truss design, Google Earth Pro, manual design to the Euro code, manual design to the BS code, AutoCAD, reinforced concrete design from A to Z, and then wind load analysis, raft foundation design. So we have a lot of courses, so you can browse through our website and start learning. All you have to do is just add to cart and then make payments, and then you have access to the courses which you can uh, which you can. So another question is, thanks for your response. What is the purpose of the pile load test? This is just an introduction to pile. So if you take our course on pile foundation design and detailing, you are going to see much more information on this topic. So like the pilot test that you mentioned, we discussed it extensively as well. So if you have any other question, especially based on our discussion here. So I have only 30 seconds left. Okay, so thank you guys for joining this live session. I believe now you have some little backgrounds on Pile Foundation, and then you have some little understanding on what to look out for. Let's say someone give you a pie cap detailing, you can now look at some one or two things to know if the work is done right or not. So thank you for joining the live session. If this is your first time on Chefdin Academy, you can subscribe to our YouTube channel so that we can get this channel to 10K subscriber. So thank you very much. See you next time.